video, we are going to take a continuous time signal for checking whether it is periodic or not. So the signal given is like this: x of t equal to 2 cos 10t plus 1 minus sin 4t plus 1, and we need to check whether signal is periodic or not. And for the periodic signal, we need to find out fundamental time period. So let's start. So over here, x of t consists of two signals, x1t, you can consider plus or minus, that won't affect much. So let's consider this as minus x2t. So comparison will give you x1t as 2 cos 10t plus 1. Comparing with standard equation, which is cos omega t. See, I have not considered amplitude and not even a phase. I have just concentrate on whatever there with t, which is nothing but frequency omega. So omega equal to 10. Omega is 2 pi by t. So that will give you t equal to 2 pi by 10. I can say this is equal to pi divided by 5. So pertaining to this, I can say x1t is periodic with fundamental time period t0 equal to pi divided by 5. Let's find out the periodicity for x2t. So x2t is sin 4t plus 1. Comparing with standard equation, this time it is a sinusoidal function. Rather, cos is also a sinusoidal function, but we precisely call cos as shifted sign. I consider this as sin omega t. Once again, I am not paying any importance to the phase. So what I will get omega as 4. So 2 pi divided by t equal to 4. That implies t equal to 2 pi by 4. In the end, t equals pi divided by 2. So once again I can say x2t is also periodic signal. This time fundamental time period t0 is pi divided by 2. So now what we have done, x of t we split it into two signals. Each signal will be proved as a periodic one with a fundamental time period calculation. Now what we will do, we consider this fundamental time period for the first signal as t1 equal to pi by 5, and for second signal it is pi by 2. And now we need to find out whether the combination of these two signals, which is x of t, is periodic or not. For that purpose, we just take the ratio of t1 and t2, which comes around to be pi divided by 5 upon pi divided by 2. Pi getting cancelled, and in the end I will get the ratio as 2 by 5. So 2 by 5, once again, I can consider this as a ratio of two integers. So I'm getting ratio of two integers after taking the ratio of a time period for a first signal and second signal. I can say x of t is a periodic signal. Now the question left is to find out fundamental time period for x of t. Now at this t1 and t2 as integers, I could have said that LCM of this t1 and t2 will be the fundamental time period. But the problem is that t1 and t2 are not integers. So what we need to do in this case, whenever such things appear, what we need to do is, let's plot x1t and x2t. So this is a plot for x1t, and let's take this is for x2t. Now fundamental time period for x1t is 5 by 5. So let's consider this time span as 5 by 5, so that this will be 2 pi by 5, then we have 3 pi by 5, over here it is 4 pi by 5, and in the end it will be 5. Let's consider I am plotting this from 0 to pi. So pi by 5 is the time period, meaning you will get a waveform like this. One cycle is completed. From pi by 5 to 2 pi by 5, second cycle is completed like this. So I can get cycles like this. Let's consider x2t. Fundamental time period for this is pi by 2. So somewhere here I will get a pi by 2, and then let's consider this is pi. So let's consider this is pi by 2 and pi. So I can get x2t whose fundamental time period is pi by 2 will be like this. So what is happening over here? The fundamental time period for x1t is this, and for x2t it is 0 to pi by 2 like this. So what is happening? Pi is that interval of time where x1 and x2 both are completing their integer cycles. So during the pi interval, x1t will complete 1, 2, 3, 4 and 5 cycles. Which is an integer. During the same time interval, x to t will complete 1 and 2 cycles. which is once again an integer. So what I can say, from 0 to pi, both the waveforms are completing their integer number of cycles. Hence, I can consider x of t is a periodic signal with fundamental time period equal to pi. Mathematically also we can find out this. See how t1 is the fundamental time period for x1t, which is nothing but pi upon 5, and t2 is the fundamental time period for x2t, which is pi upon 2. So what we will do over here, since both of them are not integers, hence we can say fundamental time period for x of t, which is t0, will be nothing but LCM of numerator of first number and numerator of second number upon GCD, greatest common divisor, GCD of denominator of first number and denominator of second number. So if we apply this formula over here, I can get T0 as LCM of numerator 1 is pi, numerator 2 is also pi, upon GCD, denominator of 1 is 5 and denominator of 2 is 2. So if we solve this, we'll come to know LCM of pi and pi is nothing but pi, and GCD of pi and 2 is 1. So in the end, I can say T0 equal to pi. So if time periods are not integers, we can use this formula. Thank you.